Okay, on this problem, what we're going to be doing is we're going to find the points of inflection and we're going to discuss the concavity of the function again. This time we're going to find the points of inflection as well. I think this one is much easier to take the derivative rather than doing product rule. Just spending a little time multiplying out this x minus 4 times x minus 4 times x minus 4. Because I have to find those possible points of inflection, I may just want to spend time doing this, which is what I'm going to do. I'm going to multiply those two together first, which gives me x squared minus 8x plus 16. Then I'm going to take it and I'm going to multiply those two together. So I'll end up getting x cubed minus 8x squared minus 4x squared plus 16x plus 32x minus 64. Now I didn't go in order on those. I went in order that so I would have them next to each other so I could add like terms. So my function then would be x to the fourth in my add like terms while I distribute this negative through. So I get negative 12 x cubed plus 48 x to the second minus 64x. So the first derivative ends up being 4x cubed minus 36x squared plus 96x minus 64. My second derivative is 12x squared minus 72x plus 96. Now, this one, I want to find out where it's equal to 0. If there is no values where it doesn't exist, I am going to be able to factor out of 12, so it makes it easier to factor. So I get x squared minus 6x plus 8. And then I'll go ahead and start factoring this further. It'd be x minus 4x minus 2. So there's two possible points of inflection. Those are at 2 and 4. I am testing the second derivative. Now, we're also supposed to find the points of inflection. So if the concavity changes, then we'll say that the points of inflection were at 2 comma something and 4 comma something. So these are the possible points of inflection right now. I'm going to test the second derivative, so I'm going to plug 0 in for my second derivative right here. Or right here, it doesn't matter which one. When you plug in 0, you get 0 minus 0 plus 8, so you get a positive value. When you plug in 1, try 1, we have 1 minus 6, that would be a negative 5 plus 8 would give me a negative value. And then in this next part here, I'd have 5. 25 minus 30 is negative 5 plus 8 is a positive value. And I said I was trying 1 here. I meant I was trying 3. And 3 does give you a negative value. So I end up having concavity changing over here at 2. And where do I get my y value? Way back up here at the beginning. So if I plug 2 back in up here, my y equals 2 times 2 minus 4 cubed. 2 minus 4 cubed, that would be negative 2 times negative 2 times negative 2, which is negative 8, times 2, which is negative 16. Plug 4 in up here, and you end up getting 0. So the points of inflections are 2, negative 16, and 4 and 0. Your concavity is going from 0 to 2 and 4 to infinity. Those are the concave up intervals. And then the concave down interval is from 2 to 4. So that one is concave down.